Hey everybody, welcome to Introduction to Computational Media 2.0. This is the Python version. As we move through the course, you're going to hear it most frequently referred to as ICM.Py or just ICM, since all of these videos have to do with Python. This is your very first introduction to the course, and in this video, we are going to go ahead and get set up in the online editor we are using. We're going to take a look at the very start of coding with Processing.Py, and we're going to make sure that you guys are set up for success moving into future lessons. Just to clarify, the editor that we will be using is Trinket.io. It is linked in the curriculum. It is available via Google search if you're not sure how to find it. And there are other options out there. Trinket has a free version that is going to be able to do everything we need it to do. There are paid tiers as well that I've never used, but you're welcome to explore. If Trinket isn't quite your vibe, you're welcome to seek something different out. I know that the processing website has a code editor you can download specifically for working with processing and Processing.Py. Downside of that is it is a local editor, it is not online. So getting and sharing code in a classroom setting might be a little bit more difficult if you are new or you're not sure how to work within those parameters. There's also a version on Replit. I personally have found the Replit version to be a little buggy. It tends to freeze and the error messages aren't always the most helpful in my opinion, but you are welcome to try and troubleshoot that or explore that if you think it would better serve you. So I just want to make sure y'all are aware of that and you have all of your options before we get going. For the purpose of this course, we are always going to be working in Trinket and I will always be referencing Trinket, but just know that the code applies universally. Now, if you haven't already, please pause this video, head to Trinket.io, and you're going to be on a page that looks similar to mine with the caveat that you probably won't be in an account yet unless you have made one for a previous course. Because you don't have an account, you're going to find whatever button that says sign up, make an account. There might be like a login button, and when you click it, it will say sign up for account here. You're going to follow those steps and go ahead and create an account for yourself. Please make sure the username is something that you are happy with, that you'll be happy if students are seeing as well. And then we are going to go about making our very first trinket. Now I want to name at the top, this is going to be kind of a weird process the first few times, because while there is a button for new trinket, and it does have the Python option we want, people with experience, I'm very aware that we're using the sundown version of Python. It just happens to be the one that works with Processing.Py. And the syntax is the same enough that it is also going to prepare you for using Python 3 in future courses. But if we just click that button, we're going to get a blank Python file with nothing in it. And Processing.Py is a module that requires us to import the module and then to use some super specific to that module functions in order to get things to run. That can be like really overwhelming if you're new. It can be really overwhelming if you're working within a shortened class period. So instead of trying to write all that code out, we're just going to get a pre-made template. And there are two ways that you can get this pre-made template. The first is that you can just Google Trinket Python processing, and the very first link it gives you is going to say, put Python and processing.js anywhere on the web. You click it, it's going to give you this template that you can save to your account that has some starter code. All of this stuff is the stuff I was saying we would have had to write, and it can just get annoying. It is all there for you. We have also, to try and simplify this process, made a bit.ly that is just bit.ly/trinketpy that has the exact same stuff in it. This is linked throughout the curriculum. I would recommend bookmarking it, put it in a Google Classroom or whatever learning management system you use with your students, make sure they're very aware. And anytime they're going to start something new, they're just going to go here and make a copy. Your page probably looks a little different than mine because I am the original creator, but somewhere up top, you're going to see a button that either says duplicate or copy, and you're going to go ahead and click that button. Now I have already clicked that button, so I'm going to close out of this and I'm going to head to my tab over here. This is the copy that I made, and you'll notice that I renamed it. If you click in that box, you're able to rename this just by typing in whatever you want. So I can write new name, I can delete this, whatever makes sense. This is probably the most important thing for you and your students to get in the habit of. We want to make sure that this name is always something that is unique and descriptive, because all the code you write is going to become your notes for future projects. So I named this 7/31, that is today's date, and I wrote my first sketch. I could have definitely been more descriptive and described like what I'm doing in my first sketch, but for now, this is going to work for me. If you have not already, please take a second to pause the video, get your sketch set up, and then meet me back here to go through our code. Once your sketch is good to go, if it is not already, you're going to hit the run button. And that's what's going to make this gray square appear on the side with some numbers that we're going to notice change as we move our mouse around the screen. This whole area is what we call our canvas. And the biggest thing we're going to be doing this year is making things happen on our canvas. So let's take a look at the code that's driving this, make some adjustments to that code and start adding to that code. And we will use that to jump off into the rest of our learning. So first and foremost, on line 1, this is something we're never going to touch. Line 1 right now is importing the entire processing library so that we can utilize it. Later on, we're going to talk about importing our own libraries, but please just know none of this is going to work without from processing import star. The other things that are here, def setup and def draw, are two functions that are unique to Processing.Py. They do not exist in the rest of Python, and they are necessary to make our code function the way we intend it to. Within both of those, we can see that we have some other functions being run. And I'm saying within, we should notice that there's like this white space here. That indentation is really important in Python because it tells us that things indented under are inside of the function above. We're going to talk about this more in depth as we go through and get more and more confident in our Python programming. But for now, just know that when I want to add things to setup, they need to be in line indentation wise with size. And when I add things to draw, they need to be in line indentation wise with background and text. The last thing you're going to see are lines 12 and 13, this draw equals draw and run. We are never getting rid of those. Those are what's going to help our code execute and display our canvas. If those get messed up, if those get deleted, things are not going to run correctly. I want you to also just put a little sticky on this in your brain because I can guarantee at some point someone's going to accidentally delete them, and putting them back is probably going to fix our problems. So now let's take a look at what's happening inside of our functions. Inside setup, we have this size function. And if I just play by changing that 400 to a 100 and I hit run again, you'll notice the size of my canvas has changed. This is actually controlling the X and Y width of my canvas itself. I would invite you right now to just pause and take a minute to change the numbers to some different things, whatever you want. Does not need to be multiples of 100, just so you get a feel for what's happening. And then once you're done, meet me back here at 400, 400. Now, before we go into what's happening in draw, I do want to show you part of the size is tied to these numbers up here. At the beginning, before your mouse ever touches the canvas, it's at 0, 0, just like an origin on a graph. And you'll notice that as I come on the canvas and as I move my mouse across, moving to the right is going to increase the first number. Moving down is going to increase the second number. These are your X and Y coordinates, but our coordinate system in processing, and honestly in a lot of visual programming languages, is going to be the top left corner of our screen because that's actually where things turn on from. It's very hard for me to get back to 0, 0 because this canvas really wants to believe that my mouse is on top of it. But you can notice that the X coordinate values will increase as you move to the right. Y coordinate will increase as you're going down. And for now, we're just going to utilize this line 8 to keep those displayed on our canvas at all times so that we can get used to the numbers and so that we have a little bit of assistance as we try and start placing things on the canvas. Now, the other thing happening in draw is this background function. Right now it's at 200. If I were to change this to say 220, a little bit lighter, 100, a little bit darker, we can deduce that this controls the background color of our canvas. I would invite you guys to take a few minutes just to change the numbers to things that you're interested in trying. And once you think you have a good grasp, I'm just going to meet back at, actually, let's do 200 so that we can start adding to our code. So this canvas is great. It's a square. It has numbers. We can change the color. We can change the size, but nothing's really happening on our canvas yet. And that's kind of a big deal. That's the point of this course. We want things to happen on the canvas. So we need to know what processing can do for us that will allow us to put things on this canvas. So I'm going to head over to the reference sheet, which again, linked heavily throughout the curriculum. This holds everything that Processing.Py can do. Now, please note, this is specific to the module. So things that are Pythonic, that are like part of the Python language, which you can write without processing, aren't going to be in here. But things you can only do with processing is what you will find here. You are welcome to explore and click around. I'm going to be honest, if you are brand new, a lot of this might be very confusing. We're going to start small and we're going to grow as we go. You're absolutely not getting through this whole thing. So at any point in time, you are welcome to come back, explore, search for solutions within this library. We are hoping that you'll get to the point where you will know how to read this documentation and you can teach yourself. To get us started though, we are going to look at just basic shapes. So I'm going to go to 2D primitives and I'm going to click on ellipse. Once we click on ellipse, we're going to be on a page that looks like this. And this is just going to break down what the function does for me. It gives me an example of writing the function. It gives me a description. It tells me that this will draw an ellipse, also known as an oval on the screen. If I give it an equal width and height, it's a circle. And it also tells me what all of these numbers that I have to give it when I want to write an ellipse do. So I see that it has A, B, C, and D. That order is very important. It is expecting to get A in the A place, B in the B place, so on and so forth. And it tells me that A and B, that's the X and Y. It's going to tell me where the center of my circle goes. Then I have C and D, which are going to be my width and my height. So let's head over to my Trinket and let's try and add this in. So I'm going to enter down, and notice when I enter, the program is very nice to me. It tries to keep the indentation in line. I need that indentation to be in line or else I'm going to get errors. And the first thing I'm going to look at to try and fix is that indentation. And I'm actually going to add a comment first, which is another new skill we can learn right now. Comments in Python always start with a hashtag, hold shift and hit the number 3. And then I'm going to write ellipse, X, Y, width, height, to remind me what my function looks like. Now, if I were to hit stop and then run, nothing appears on my canvas because the computer does not actually read comments. That means we can leave little notes to ourselves throughout our code whenever we want to help us keep track of what's happening and remember what we did and why we did it. This is really key. You'll be doing it a lot, and it's a great habit to get into. Now, let's make something actually happen on our canvas. We're going to make a circle appear. So I'm going to hit enter and I'm going to write my ellipse right underneath my comment, again, making sure that it is in line with everything above it so I don't get indentation errors. So I'm going to start by typing the word ellipse and I'm going to open and close a parenthesis, which is where all of my parameters for this ellipse function are going to go. I realize that I type very fast, so if at any point you guys need to pause or rewind the videos, please feel free. And then I'm going to give it a coordinate for the center of my circle. Now I want to make this at the very center of my canvas. And since my canvas right now is 400 by 400, I'm going to stick 200, 200 in there. And then for a width and height, let's start out by making this a circle. So I'm going to put 50, 50. And I'm also just going to make sure, it looks like I have a typo. I put a period instead of a comma. Every number has a comma between it. That's just how the computer is parsing out which is which. Once I have all of this, I'm again going to hit stop and then run. And this is just going to run my new code. And we'll see that I have a lovely little circle in the middle. Now, just like we did with the background and the size value, this is a great moment to start changing things. So if I were to change, for example, the height to 100, I now have an oval. I could change the width to 75, and I have a slightly differently shaped oval. I can also experiment with the X and the Y. So let's say I move the X to 100. That value is decreasing, so I'm going to expect that it moves left on the X-axis. And if I hit stop and run, it did in fact move left on the X-axis. I can increase the Y value, and increasing should mean moving down. So I can hit stop and run, and it should move down. I can also utilize these coordinates. If I put my mouse in the about center, it says 101, 251. That's almost my coordinates. I'm probably not in the exact middle, but that's how I can use these numbers to help me place shapes. Now, before you move on to future lessons, I would encourage you to perhaps try moving the shape around a little bit more, maybe making a second one. Just familiarize yourself with what it's like to write and adjust things that are going to show up in a computational program. Once you are good here, you can hit save. That will make sure that you have this for the future. And then you can always head over to My Trinkets. Please don't judge that this is terribly unorganized. I am in desperate need of doing some organization before the year starts. But in this section of my trinkets, you can create folders and you can drag and drop your trinkets into folders to keep yourself a little bit more organized, especially when you're using these as notes, when you're having students use these as notes. I'd recommend maybe making a folder for each unit or each topic so that it's easy for them to reference what they were creating. You can explore with the organization all you want, and I will see you guys back for more learning in the future. Bye.